Hello everyone, my name is Radu Horoiu. I'm a professional services engineer at Infinet Wireless. Thank you very much for taking the time to join our webinar. Today we are going to discuss about the Infinet Wireless solutions for smart cities. The agenda includes 4 items. I will start by explaining what does smart city mean and what are the advantages of the wireless network implementations in smart city projects. Next, I will list some of the most important smart city components, highlighting the specific network requirements in each case. The third item will be about the smart city solutions offered by Infinet Wireless and the key benefits of the Infinet units when compared to equivalent products. And in the last item, I will do a quick roundup of some of the many Infinet success stories. First of all, what does smart city mean? What is a smart city? A smart city is a modern urban area in which a multitude of digital technologies are implemented with the purpose of improving the quality of life for its citizens, increase the operation efficiency of the city's services, and increase competitiveness. When discussing about smart cities, obviously the key term is connectivity. Public internet access should be available everywhere because these days everyone wants to stay connected all the time. Then all public service systems should be interconnected in order to ensure a seamless and efficient operation of all services. The Internet of Things is a rapid growing trend across many sectors, and it also plays a key role in the development of smart cities. But connectivity is not all. Data transport, interpretation, and correlation are also crucial. Thus, the collected data must be transmitted to the control centers error-free and as quickly as possible. This means that high-performance network equipment is required. Because it's hard to imagine a smart city without wireless implementations, let's look over some of the advantages of deploying wireless networks compared to the wired solutions. First, the wireless network implementations are usually cheaper, especially in situations when there is a long distance of several kilometers, for example, between the facilities that need to be connected. Also, the installation is much easier to perform. In some cases, installing cables in the city over such long distances could be very hard to do or even impossible. Then, the deployment time is greatly reduced in case of wireless solutions because the installation is very simple, close to the plug-and-play concept. Another important advantage is that wireless networks are more flexible and scalable. It is very easy to expand the wireless network or move the units from one place to another and establish links at different locations. And finally, the maintenance of wireless systems is very easy to perform. In most cases, just one person can do it from one location. Also, if something goes wrong with the hardware equipment, it takes much less time and effort to pinpoint and fix the problem, as opposed to the wired solutions where the issues can be harder to locate and repair in a short amount of time. Moving on to the second item of today's presentation, where I will list some of the most important smart city components that can benefit of the broadband wireless access solutions. With almost every person owning a smartphone these days, it would be impossible to call a city smart if it didn't provide wireless internet access in all the densely populated areas. From bus stations, subway tunnels, and airports to public institutions, libraries, parks, and so on, every important public place must have Wi-Fi coverage. For the backhaul part of the Wi-Fi networks, or even for small cells, broadband wireless access devices can be used to carry the data towards the core networks. The BWA units must offer high capacity to deal with the huge amounts of data demanded by the increasing number of users and applications. Another important aspect is security to keep the user's personal data safe. And also, there must be support for multiple services, so the devices must have strong QoS capabilities to be able to handle the different types of services like internet, video, voice, data transfer, and so on. The second crucial component of a smart city that I want to point out is video surveillance. The CCTV infrastructure is essential in preventing crime and keeping the citizens safe. Thus, all the busy places in the city, especially the public transport, must be covered by the CCTV network. The video streams generated by the cameras can be easily transmitted to the surveillance centers using broadband wireless devices that satisfy the network requirements for this type of application. Firstly, because usually the live video images must be available in more than one location, the BWA units must be able to handle the multicast traffic, so IGMP must be supported. Secondly, the delay and jitter must be low to ensure a smooth transmission of the video stream. It is extremely important for the video data to be delivered without a glitch, or else the system will not fulfill its purpose, which is to see when a crime is committed and help identify the criminal as soon as possible. And of course, powerful QoS functionalities must be available to enable the prioritization of the video data. The next important smart city component is the intelligent traffic light system. Traffic jams are a major issue in a large city, thus a vehicle traffic management system is mandatory to reduce congestion and increase the mobility. This kind of system combines the conventional traffic lights with an array of sensors and cameras that transmit data to a central unit, which uses it to intelligently route the traffic so that the congestion is greatly reduced. The sensor and camera data can be easily transmitted to the central unit using BWA equipment installed on the same masts or poles as the traffic lights. The first network requirement in this case is low delay, because if the traffic data does not arrive quickly enough at the central unit, the system may not work properly or even make things worse. Then, high availability is also very important, because this type of system must be fully operational at all time, 24/7. QoS capabilities are required too, because other types of data may travel through the same network and the critical data must be prioritized. And the last smart city component that I want to highlight that can benefit of the broadband wireless access network's deployment is high-speed wireless connections between buildings. In a smart modern city, the public facilities like schools, universities, libraries, hospitals, administration buildings, and so on must be interconnected in order to ease the interaction between them and with the citizens as well, ultimately leading to an increase in public service efficiency. The specific network requirements in this case are high capacity due to the large number of users and applications, security to ensure personal and sensitive data protection, and high availability, because some of the public services must be operational 24/7, especially the medical facilities. Moving on to the next item, where I will present the smart city solutions offered by Infinet Wireless. In the picture, you can see a typical network topology built using Infinet units that satisfies the connectivity needs of the smart city components listed earlier: Wi-Fi access points, video surveillance systems, intelligent traffic lights, and high-speed links between buildings. Usually, point-to-multipoint solutions are used for the last-mile connectivity, while higher-speed point-to-point solutions are deployed for the backhaul connectivity to the control and administration centers. The base station coverage ranges in excess of 10 kilometers in the urban environment, and the IP video cameras can be connected directly to our subscriber terminals, which have an additional Ethernet port that has PoE out, so it can also power the camera. Infinet Wireless has a few key benefits which can help the smart city implementation across the globe. The first benefit is higher capacity. Infinet Wireless provides unmatched coverage and throughput. Our cost-effective point-to-point solutions provide an unprecedented net capacity of up to 1 gigabit per second over long distances in both line-of-sight and non-line-of-sight conditions. The point-to-multipoint solutions offer up to 240 megabits per second. The spectral efficiency that we can achieve of up to 14 bits per second per hertz is still unmatched by any of our competitors. Next, our new QMXB base station benefits of an advanced smart beam antenna, which helps mitigate interference and enables it to operate without issues in the most polluted RF environments. In contrast with the legacy sectorial antenna, where the radiation pattern is fixed within the 90 degrees of the sector coverage, the new smart antenna of the QMXB unit uses an adaptive beam that is electronically steered towards the CPEs under operation. Depending on the working frequency, the gain of the beamforming antenna in each of the 15 possible positions varies between 21 and 23 dBi. The QMXB base station is highly recommended for urban areas where non-line-of-sight situations can occur and the 5 GHz spectrum is very congested. This makes it highly suitable for smart city projects. As mentioned earlier, the Infinet units have the unique ability to operate in both line-of-sight and non-line-of-sight conditions. This gives us a clear advantage, especially when we are talking about smart city projects. When you need to wirelessly interconnect many devices like cameras, sensors, access points, and so on, most of them installed at street level, it can be a great challenge to find a clear line of sight all the time. This is why it is of great help to use broadband wireless units that can establish good connections in non-line of sight conditions as well. Infinet Wireless also offers the best quality to price ratio. Combining its advanced MIMO radio technologies with the best data management and transmission protocols available in the marketplace today, Infinet Wireless allows its customers to benefit from a carrier-grade infrastructure for all their data requirements, supporting bandwidths from as low as 1 megabit per second up to 1 gigabit per second on a pay-as-you-grow basis. The wide range of frequency bands supported by the Infinet Wireless family of products is also a major advantage. We offer devices that can operate using frequency bands ranging from 2 GHz all the way up to 6.4 GHz, both licensed and unlicensed, all supporting advanced networking features, interference mitigation, and quality of service. We have point-to-point solutions in 2, 3, 4, 5, and 6 GHz, and point-to-multipoint solutions in 3, 5, and 6 GHz. Besides the key advantages listed in the previous slide, the Infinet units come with a lot more benefits that can really help you deploy some of the best performing broadband wireless access networks in the world today. First, our products ensure data transmission with low delay and jitter. For instance, the typical one-way latency for the Infilink XG units can be as low as 0.5 to 3 milliseconds depending on the frame size. To facilitate the deployment of critical applications like intelligent traffic control or public transport video surveillance, and ensure the protection from unauthorized data access, Infinet products benefit from a strong set of security features. Unit access is done via password-protected CLI and web interface. There is support for SSH and HTTPS, and management VLANs can also be used to increase the security even further. The radio protocol, which enables the communication between the units, uses an advanced 128-bit over-the-air data encryption. In terms of network security protocols, the Infinet units feature built-in network storm and flood protection, a strong IP firewall that allows you to filter the traffic based on any criteria, tunneling, and VLANs. The optimal operation of multiple concurrent services like video, voice, internet, data transfer, and so on is facilitated by the powerful QoS feature set provided by the Infinet devices. First, the RTP traffic is automatically recognized and then prioritized accordingly. Then there is support for advanced prioritization according to the different traffic classification standards like 802.1p, TOS, and diffserv. We also offer the possibility to manipulate the QoS tags, so if you need, you can lower or increase the priority of certain service types to further optimize the performance of your network. There are 17 physical priority queues for the R5000 units and 4 physical priority queues for the Infilink XG. These represent fully customizable physical data channels which you can use to make your own traffic prioritization system based on virtually any criteria. In addition, the R5000 devices also have 200 logical queues for a more advanced prioritization. Traffic shaping can be used to ensure a smooth output packet rate, lowering the delay and jitter values. Also, dynamic bandwidth allocation allows you to efficiently distribute the available bandwidth between the applications or services using QoS classes. Moving on, we will talk about some important radio technologies implemented by Infinet Wireless, and I would like to start with the Dynamic Marker Access Protocol for the wireless medium, or polling, which is very useful especially in point-to-multipoint topologies because it helps reduce delay, improves resource utilization efficiency, and thus enhances the overall performance of the network, especially in urban environments. The TDMA medium access method is also available, helping reduce jitter and allowing you to adjust frame period and the uplink-downlink ratio. The auto bitrate control feature uses a smart adaptive rate algorithm that keeps track of the optimal modulation, and the ATPC or automatic transmit power control makes sure the units operate within the optimal transmit power limits. Both these features help ensure high availability and throughput. Instant DFS helps in selecting the clearest RF channel very quickly in a few microseconds so that the units can always operate using the least interfered frequencies. And we also provide built-in tools for in-depth radio channel analysis, like for example Spectrum Analyzer and the Graphical Antenna Alignment tool. The Infinet units support a vast number of networking features. I will list just a few of the most important ones in this presentation. First, I want to state that the R5000 units offer full layer 2 switching capabilities, so we have full support for VLANs, STP, multicast, Q-in-Q, link aggregation, and so on. Both static and dynamic routing are available. Traffic filtering can be done up to layer 4. We also have multiple NAT, DHCP client, server and relay capabilities, tunneling, and Infinet over Ethernet that enables the Mint encapsulated packets to travel through the external Ethernet networks. As I mentioned earlier, one of the most important components of the smart city is video surveillance. In order to keep people safe and reduce crime in a city, a huge number of security cameras must be installed, thousands or even tens of thousands. Of course, this means that the wireless network must be able to properly handle the live video traffic. Infinet Wireless units support IGMP snooping for multicast traffic management and advanced QoS policies which allow you to prioritize different traffic types. Our products also offer availability of up to 5 nines across distances of up to 20 to 30 kilometers, which enable you to transmit high-definition video without interruptions. It is very important to mention that our CPEs have an additional Ethernet port that has PoE out, so it can also power a camera. Real-time communication support is another important benefit for applications like video conferencing and IP telephony, which may be implemented in modern public institutions. In this sense, Infinet Wireless offers an advanced solution based on the proprietary Mint protocol coupled with QoS policies for automatic recognition and prioritization of RTP traffic. The TDMA technology is also available to help further improve the jitter values. For the network management, you have the possibility to use VLANs to restrict and secure access to the units. SSH, Telnet, and Remote Shell can be used for connectivity and management as well. SNMP version 1 to version 3 and S-Flow are also supported. The web interface is a very intuitive management tool that includes complex configuration and monitoring options. And firmware upgrades can be performed over the air, further facilitating the management of the Infinet Wireless network. Infinet products are very easy to use. All our devices are compact and light, so in most cases the installation can be done with minimum effort. The alignment of the antennas can also be easily performed with help from the built-in alignment tool. We provide unified management using the InfiMonitor platform and over-the-air management across the Mint network, so that in most cases one person is enough to do the maintenance from only one location. Reliability and robustness are also some of the strong points of the Infinet Wireless units. Their operation in the most diverse climatic conditions and geographical topologies has been proven for more than 10 years. Each unit features a built-in surge protector and an IP66, IP67 compliant aluminum enclosure. The mean time between failures is 150,000 hours for all models. By choosing the Infinet products, you have the possibility to optimize the total cost of ownership. First, the capacity is upgradable, so you can lower your capex and apply a pay-as-you-grow strategy. Then, the OPEX is minimized due to the high reliability and the enhanced management options. The high MTBF figure means that there is a good chance that you won't ever have to replace any unit due to failures. Usually, you just install and configure the devices and then you forget about them. And finally, our technical support team is available 24/7 to quickly help you with any issues you might encounter during the installation, configuration, or maintenance of the Infinet units. We have arrived at the last topic of today's session, which is about some of the many success stories featuring Infinet Wireless solutions. And I would like to start with the OptiBus transport company in León City, Mexico. OptiBus operates a large network of buses within the city and its municipal areas. Crime levels within the city are considered high and have increased in the last 3 years by up to 70%, so in order to keep passengers safe, the company maintains a network of CCTV cameras to monitor, prevent, and discourage crime. The network was operated through an outdated Motorola Canopy wireless system, which was installed in 2003, and it offered a maximum throughput of 4 megabits per second per base station sector, making real-time video transmission from all cameras almost impossible. So a need for increased capacity was obvious, not only to ensure the safety of the passengers, but also to enable OptiBus to look at ways to collect other passenger data across the network. The Infinet solution for this project was comprised of 5 Infiman 2x2 base stations, 55 subscriber terminals, and 3 Infilink 2x2 point-to-point systems. The main benefits for OptiBus after implementing this project were improved real-time video from the CCTV cameras, more network capacity, reduced costs in employment because less staff is required, and aftercare, technical and post-sale service were offered by Infinet Wireless as well. Next, we have the Galați city in Romania, where our partner Mobilis has implemented a new intelligence system to increase traffic safety and prevent crime. As an important economic center in Romania, the municipality of Galați wanted to increase crime prevention and the safety of its citizens, and it also acknowledged the need for an intelligent traffic management system due to the large number of vehicles passing through the major intersections. Thus, the requirement was to provide a feasible network solution to manage road traffic and improve surveillance systems to prevent crime in the city. The implemented solution was comprised of 18 Infilink XG units, 9 MMXBS base stations, and 43 subscriber terminals. The new stable and secure Infinet network was able to provide high-performance connectivity for the video surveillance and intelligent traffic management systems. The next success story comes from Neiva City in Colombia, where the existing video surveillance system deployed using an optical fiber infrastructure had to be extended. Because the cost of deploying yet more fiber-based solutions was deemed too high and would have taken a long time to deploy, the local authorities have decided that a wireless system would be more appropriate and more effective. The main challenges that had to be overcome were the poor line of sight, the high level of interference, and the deployment time, which had to be very short. The deployed solution consisted in both point-to-multipoint and point-to-point devices, 9 base stations, 1 MMXB and 8 SMNB, 35 subscriber units with 8 megabits per second maximum throughput, limited by license, and 20 Infilink 2x2 Lite devices, 8 of which were limited to 8 megabits per second. The wireless solution proved to be more cost-effective compared to fiber optic cabling, and as a result of the deployment, crime was reduced by 32%. And the last example I want to present is the CCTV infrastructure in Banbury, England. The requirements in this case were to provide high-quality, cost-effective wireless CCTV connectivity in the center of Banbury town. The solution had to be flexible to allow the deployment of new cameras, and the operation costs had to be reduced by eliminating the need for fixed-line leasing. The implemented solution was based on the Infilink 2x2 Pro MMX point-to-point devices. After the deployment, the need for fixed-line rental was eliminated, thus the operating costs were greatly reduced. The new platform provides high capacity for real-time video streams, and it is scalable to allow future extensions or modifications. Thank you once again for your time, and I hope to see you again during our next webinar.